The first Liberty ship that Admiral Karl Donitz observed through his periscope photographs in October 1942 looked like every other Allied merchant vessel his U-boats had been sinking across the Atlantic, until his intelligence officers calculated the impossible numbers. SS Robert E. Peary, launched just 4 days and 15 hours after its keel was laid, represented American shipbuilding capabilities that seemed to mock the laws of industrial physics. "This cannot be accurate," Donitz muttered to his staff at U-boat headquarters in Lorient, studying reconnaissance reports that claimed American shipyards were launching complete merchant vessels faster than Germany could produce submarines to sink them. "No nation can build ships at such speeds. Our calculations must be wrong." These were experienced naval professionals who had mastered submarine warfare and understood maritime logistics better than any military force in history. They had systematically analyzed Allied shipping patterns, calculated tonnage requirements, and developed mathematical models that proved German U-boats could sink merchant vessels faster than any conceivable replacement rate. They had no way of knowing they were witnessing the beginning of the greatest industrial mobilization in human history, or that America's Liberty ship program would produce over 2,700 vessels in less than 4 years, fundamentally overwhelming German submarine warfare through sheer numerical abundance that rendered tactical excellence irrelevant. If you want to discover more incredible stories of how American industrial might change the course of World War II, make sure to subscribe to our channel and hit that notification bell. Admiral Karl Donitz stood before the massive plotting board at his Lorient headquarters in September 1942, studying tonnage calculations that had guided German submarine strategy since the war's beginning. As commander of the Kriegsmarine's U-boat force, Donitz had developed mathematical models that proved German submarines could achieve decisive victory by sinking Allied merchant shipping faster than enemy shipyards could replace the losses. The German submarine campaign that Donitz commanded had achieved remarkable success during 1940 and 1941, sinking over 3 million tons of Allied shipping while demonstrating tactical superiority that seemed to validate his strategic calculations. U-boat crews had mastered wolfpack tactics, night surface attacks, and operational coordination that consistently outperformed Allied convoy defenses. The tonnage war that Donitz fought relied on systematic analysis of Allied shipping requirements and replacement capabilities. His staff calculated that Britain required 18 million tons of shipping annually to maintain war production and civilian survival, while Allied shipbuilding could replace only 1.5 million tons per year under optimal conditions. Korvettenkapitän Günther Hessler, Donitz's operations chief and statistical expert, had developed targeting priorities that emphasized efficient tonnage destruction through attacks against loaded eastbound convoys carrying vital supplies to Britain. This systematic approach maximized strategic impact while minimizing submarine exposure to increasingly effective Allied anti-submarine countermeasures. The mathematical model that justified unlimited submarine warfare assumed that German U-boats could maintain sinking rates exceeding 600,000 tons monthly, while Allied replacement production remained limited by traditional shipbuilding methods, skilled labor shortages, and resource constraints that characterized European industrial capabilities. The intelligence reports that reached German submarine headquarters during early 1942 indicated increasing Allied shipping construction, but suggested production rates that remained well within German calculations for sustainable attrition warfare. British shipyards appeared to be approaching maximum capacity, while American production was just beginning to accelerate from peacetime levels. The U-boat construction program that supported Donitz's campaign aimed to maintain 300 operational submarines through systematic production schedules that delivered 20 to 25 new boats monthly from German and occupied European shipyards. This construction rate, combined with improving submarine technology and crew training, seemed adequate to overwhelm Allied shipping replacement capabilities. The strategic timing that Dönitz had planned called for decisive submarine victory before American industrial mobilization could achieve full effectiveness. German calculations assumed that American shipbuilding, while potentially significant, would require years to reach production levels that could offset continued German submarine successes. The crew training programs that prepared German submarine personnel reflected years of tactical refinement and technological advancement that had made U-boat operations the most effective anti-shipping campaign in naval history. These experienced crews possessed technical competence and tactical expertise that seemed impossible for rapidly expanding Allied naval forces to match. The technological innovations that enhanced German submarine effectiveness included improved torpedoes, radar detection equipment, and communication systems that enabled coordinated wolfpack attacks against Allied convoys. These advances suggested continuing German advantages in underwater warfare that would maintain tactical superiority regardless of Allied numerical increases. Most critically, the industrial intelligence that reached German submarine headquarters indicated that American shipbuilding remained limited by traditional construction methods, skilled labor shortages, and resource allocation problems that would prevent rapid expansion to levels capable of offsetting German submarine successes. As October 1942 approached, Admiral Dönitz remained confident that his submarine campaign would achieve decisive victory through systematic application of superior German tactical expertise and mathematical precision that proved Allied shipping replacement was impossible at rates sufficient to offset continued U-boat successes. Henry J. Kaiser stood on the deck of his Richmond Shipyard No. 2 in California, watching teams of welders work around the clock on what would become the fastest-built merchant vessel in maritime history. The industrialist who had revolutionized dam construction and highway building was about to apply mass production techniques to shipbuilding that would create industrial capabilities exceeding anything achieved in human history. The Liberty Ship program that Kaiser championed represented a fundamental departure from traditional shipbuilding methods that had limited production rates since the dawn of maritime history. Instead of relying on skilled craftsmen who hand-fitted individual components, Kaiser's shipyards would use prefabricated sections, assembly line techniques, and mass production methods that transformed complex vessels into standardized products. The design standardization that made rapid construction possible eliminated the custom engineering that had characterized maritime construction for centuries. Liberty ships used identical plans, interchangeable components, and simplified systems that enabled shipyard workers with minimal experience to assemble complex vessels using industrial methods adapted from automobile manufacturing. The welding revolution that Kaiser pioneered replaced traditional riveting with electric arc welding that could be learned in weeks rather than years of apprenticeship training. This technological innovation enabled shipyards to employ women, minorities, and inexperienced workers who could achieve production rates that exceeded skilled craftsmen using traditional methods. The prefabrication techniques that Kaiser developed included construction of complete ship sections in specialized workshops before assembly at traditional shipways. This parallel production enabled multiple teams to work simultaneously on different vessel components, dramatically reducing construction time while maintaining quality standards through systematic quality control procedures. The workforce mobilization that supported Liberty Ship construction recruited workers from across America, including women who had never seen shipyards, farmers seeking wartime employment, and minorities excluded from traditional maritime trades. This diverse workforce received intensive training that enabled rapid skill development while demonstrating democratic industrial capabilities. The construction records that Kaiser's shipyards established challenged fundamental assumptions about industrial limitations and human organizational capabilities. The SS Robert E. Peary, completed in 4 days and 15 hours, demonstrated that American industrial methods could achieve production rates that violated traditional manufacturing assumptions. The raw material logistics that supplied Kaiser's shipyards included steel from Pittsburgh, engines from multiple manufacturers, and components from thousands of subcontractors across America. This supply chain coordination demonstrated organizational capabilities that exceeded anything achieved in peacetime while maintaining production schedules that seemed impossible under wartime conditions. The quality control procedures that maintained vessel seaworthiness despite rapid construction included systematic inspection, standardized testing, and continuous improvement methods that ensured Liberty ships met maritime safety standards while achieving unprecedented construction speeds. These procedures demonstrated that mass production could maintain quality while achieving quantity. The technological innovations that supported rapid shipbuilding included portable welding equipment, specialized lifting machinery, and communication systems that coordinated complex assembly operations involving thousands of workers. These advances represented industrial capabilities that exceeded anything available to European shipbuilders. The cost-effectiveness that Liberty ship production achieved included construction costs under $2 million per vessel, while maintaining delivery schedules that provided 3 new ships daily at peak production. This combination of speed, quality, and economy demonstrated American industrial efficiency that challenged fundamental assumptions about wartime production capabilities. As 1942 ended, Kaiser's shipyards were approaching production rates that would soon shock German submarine commanders who had based their entire strategy on mathematical calculations that assumed American shipbuilding could never achieve replacement rates sufficient to offset continued U-boat successes. January 1943. The intelligence reports that reached Admiral Dönitz's headquarters carried numbers that his staff initially dismissed as Allied propaganda designed to discourage German submarine operations. American shipyards had delivered 646 merchant vessels in 1942, including 312 Liberty ships that averaged 42 days construction time from keel laying to delivery. These figures seem to violate every assumption about industrial capacity and maritime construction. The statistical analysis that German naval intelligence conducted revealed production trends that challenged fundamental understanding of shipbuilding limitations and industrial mobilization. American construction rates were accelerating monthly, with individual shipyards achieving delivery schedules that exceeded total German merchant construction while maintaining quality standards adequate for Atlantic service. Kaiser's Richmond shipyard had achieved the impossible by launching Liberty ships every 10 days while maintaining parallel construction of multiple vessels that utilized assembly line techniques adapted from automotive manufacturing. The yard employed over 90,000 workers operating in 3 shifts that maintained continuous production schedules regardless of weather, labor disputes, or material shortages. The workforce demographics that supported American shipbuilding included 200,000 women who performed welding, assembly, and inspection tasks with competence that exceeded traditional maritime craftsmen. This utilization of previously untapped human resources demonstrated democratic society's ability to mobilize total population capabilities through training and opportunity rather than coercion. The Bethlehem Steel Shipyard in Baltimore had established construction records that approached mass production rates while building Liberty ships and specialized vessels simultaneously. The yard's integration of steel production, ship assembly, component manufacturing created vertical integration that eliminated supply chain delays while maintaining quality control throughout the production process. The technological innovations that enabled rapid construction included prefabricated superstructures, modular engine installations, and standardized electrical systems that reduced assembly time while improving vessel reliability. These advances represented engineering solutions that challenged traditional assumptions about maritime construction, complexity, and customization requirements. The quality assurance procedures that maintained vessel seaworthiness, despite unprecedented construction speeds, included systematic testing, continuous inspection, and performance monitoring that ensured Liberty ships met operational requirements for Atlantic service. The vessel's combat performance validated American production methods while demonstrating that quantity and quality could coexist. The economic efficiency that American shipbuilding achieved included construction costs that declined as production rates increased, demonstrating economies of scale that traditional European methods could not match. Liberty ships cost less per ton than German submarines, while providing cargo capacity that multiplied Allied strategic capabilities. The supply chain coordination that supported American shipbuilding included steel deliveries from multiple sources, engines from dozens of manufacturers, and components from thousands of subcontractors whose production was synchronized through logistics management that exceeded any previous industrial achievement. This organizational capability demonstrated American business expertise applied to military production. The geographic distribution of American shipbuilding included yards on both coasts, the Great Lakes, and inland waterways that created production capacity exceeding total European shipbuilding while providing strategic redundancy that made the program immune to enemy attack. This distributed manufacturing demonstrated strategic planning that considered both efficiency and security. The strategic impact of American shipbuilding became apparent as Liberty ship deliveries exceeded 140 vessels monthly by mid-1943, providing cargo capacity that overwhelmed German submarine sinking rates while enabling sustained offensive operations across multiple theaters. The mathematics of Atlantic warfare had fundamentally shifted in favor of Allied industrial abundance. The psychological warfare effects of publicized American shipbuilding achievements included German recognition that their submarine campaign faced industrial opposition that exceeded tactical solutions. The production miracle demonstrated American capabilities that challenged German assumptions about democratic inefficiency and industrial limitations. June 1943. Korvettenkapitän Günther Hessler stared at the latest intelligence summaries spread across his desk at U-boat headquarters, struggling to comprehend statistics that seemed to mock every mathematical model that had guided German submarine strategy. American shipyards had delivered 1,949 merchant vessels in the first half of 1943, including 1,087 Liberty ships that averaged 27 days construction time. The numbers were impossible, yet they were verified by multiple intelligence sources. The tonnage calculations that had justified unlimited submarine warfare now revealed a strategic catastrophe of unprecedented proportions. German U-boats were sinking approximately 300,000 tons of Allied shipping monthly, while American shipyards alone were delivering over 1.2 million tons of new merchant vessels during the same period. The mathematical foundation of German naval strategy had collapsed. The production acceleration that American shipyards achieved throughout 1943 demonstrated industrial capabilities that exceeded German understanding of manufacturing limitations and human organizational potential. Kaiser's Richmond shipyard had reduced Liberty ship construction time to an average of 18 days while maintaining simultaneous production of multiple vessels using techniques that seemed to violate fundamental principles of maritime construction. The workforce expansion that supported American shipbuilding included over 1.7 million workers employed in maritime construction, representing mobilization of human resources that exceeded total German industrial employment in all sectors. This demographic commitment demonstrated democratic society's ability to reorganize entire populations for military production while maintaining civilian economic functions. The quality maintenance that American shipyards achieved despite unprecedented production speeds included systematic testing procedures that ensured Liberty ships met operational requirements for Atlantic service under combat conditions. German naval analysis confirmed that American mass-produced vessels performed adequately in convoy operations while providing cargo capacity that overwhelmed submarine interdiction efforts. The cost-effectiveness that American production methods achieved included construction expenses that declined as volume increased, demonstrating economies of scale that traditional European shipbuilding could not match. Liberty ships cost approximately $1.8 million each, while providing 10,000-ton cargo capacity that multiplied Allied strategic capabilities exponentially. The technological standardization that enabled rapid American construction included interchangeable components, simplified systems, and modular design that eliminated customization requirements while maintaining operational effectiveness. This engineering approach represented fundamental departure from European maritime traditions that emphasized individual craftsmanship and custom engineering. The geographic distribution of American shipbuilding capacity included 18 major shipyards producing Liberty ships, while dozens of additional facilities constructed specialized vessels, creating production redundancy that made the program immune to enemy attack, while providing strategic flexibility that exceeded any previous industrial achievement. The strategic transformation that American production achieved became apparent as Allied shipping tonnage increased monthly, despite continued German submarine successes. The mathematics of Atlantic warfare had shifted decisively in favor of industrial abundance that rendered tactical excellence strategically irrelevant. The psychological impact on German submarine crews included recognition that their tactical achievements could not influence strategic outcomes when facing industrial opposition of such magnitude. U-boat commanders reported declining morale as crews understood that sinking individual ships had become meaningless against American replacement capabilities. The operational futility that German submarine warfare faced became mathematically demonstrable as American shipyards delivered 3 new vessels for every one that U-boats managed to sink. The strategic equation had become impossible for German forces to resolve through improved tactics, increased submarine production, or enhanced operational efficiency. As 1943 continued, German naval leadership would be forced to confront the reality that American Liberty ship production had rendered submarine warfare strategically obsolete through industrial capabilities that exceeded any conceivable tactical response. May 1945. Admiral Karl Dönitz, now Führer of a collapsing Third Reich, reviewed the final statistics of the Atlantic Convoy War that had consumed German submarine forces and ultimately failed to prevent Allied victory. American shipyards had delivered 2,751 Liberty ships, plus thousands of other merchant vessels, creating merchant marine capabilities that had overwhelmed German submarine warfare through sheer numerical abundance rather than tactical superiority. The mathematical conclusion that German submarine warfare had reached demonstrated the futility of tactical excellence against industrial supremacy of unprecedented scale. German U-boats had achieved remarkable individual success, sinking over 3,500 Allied ships during the war. But American shipbuilding had replaced these losses, while adding net tonnage that enabled sustained Allied offensive operations across multiple theaters. The production totals that American industry achieved during World War II included not just Liberty ships, but specialized vessels, naval combatants, and support craft that collectively exceeded all other nations' maritime construction combined. The United States had built over 5,000 merchant vessels during the war, while simultaneously constructing the largest navy in history and supporting global coalition warfare. The workforce transformation that American shipbuilding achieved included permanent changes in industrial employment that opened maritime trades to women and minorities, while demonstrating democratic society's ability to mobilize human resources through opportunity and training rather than coercion. These social changes influenced post-war economic development and civil rights progress. The strategic validation that Liberty ship production provided confirmed that democratic industrial systems could achieve sustained production rates that exceeded totalitarian alternatives while maintaining quality standards and worker morale through voluntary cooperation. This demonstration influenced Cold War economic competition and alliance structures. The technological legacy that Liberty ship construction created influenced post-war shipbuilding through welding techniques, prefabrication methods, and mass production approaches that revolutionized maritime construction worldwide. The industrial innovations developed during wartime production continued influencing civilian shipbuilding long after military requirements ended. The economic efficiency that American shipbuilding achieved included cost reductions, quality improvements, and productivity gains that demonstrated free enterprise capabilities when mobilized for national objectives. The program's success supported post-war American economic leadership and international trade expansion that characterized the subsequent decades. The international cooperation that Liberty ship construction enabled included technology transfer, workforce training, and industrial assistance that helped rebuild Allied maritime capabilities while demonstrating American commitment to coalition warfare and post-war reconstruction. This cooperation created foundations for NATO alliance and international economic integration. The German prisoners of war who worked in American shipyards during the conflict witnessed industrial capabilities that contradicted Nazi propaganda about democratic inefficiency and economic weakness. These experiences influenced post-war German reconstruction and Atlantic Alliance development through first-hand knowledge of American industrial competence. The post-war analysis conducted by German naval experts confirmed that submarine warfare could not have achieved strategic victory against American industrial mobilization, regardless of tactical improvements or increased U-boat production. The mathematics of industrial warfare had rendered traditional military approaches obsolete when facing overwhelming productive capacity. The Liberty ship service record that extended through the Korean War, Vietnam conflict, and beyond demonstrated the durability and effectiveness of wartime construction methods that had emphasized speed and economy over traditional craftsmanship. Many vessels remained operational for decades, validating American production decisions. The final irony that Admiral Dönitz faced as he surrendered German forces was recognition that his submarine campaign had been mathematically doomed from the moment American shipyards began applying mass production techniques to maritime construction. The 2,751 Liberty ships represented not just industrial achievement, but strategic revolution that had rendered traditional naval warfare obsolete through overwhelming abundance. If this incredible story of how American industrial genius overwhelmed German submarine warfare amazed you, Make sure to subscribe to our channel for more untold tales of how democratic innovation changed the course of history forever.